Hi everyone, this is the presentation on automated detection of label errors in semantic segmentation datasets via deep learning and uncertainty quantification by Marco Reese and myself. You probably all know semantic segmentation, which is a pixel-wise classification task of image content which can be performed by deep neural networks. However, deep neural networks produce errors and therefore uncertainty quantification is desirable at runtime. In related work, uncertainty quantification has been done for semantic segmentation on pixel level. In a prior work, colleagues and I did this on a level of connected components. So for each predicted connected component, we can get an uncertainty estimate via a method that we call metaseg, which performs a meta classification in order to predict or estimate a probability of observing a false positive versus observing a true positive in a predictive manner. And this can be used also to detect label errors. The task of label error detection has been pursued for classification by Northcott and others in 2021. However, for semantic segmentation, to the best of our knowledge, we are the first ones to do so. So our method works as follows. We feed an input image through a deep neural network. We get a prediction like that connected component over here of a human being that is not present in the ground truth. So in the evaluation, this would be a false positive. And then we can use the confidence estimation via meta classification to get an estimate how likely this is going to be a correct prediction. And if this is very likely to be correct according to our uncertainty quantification, then this might be a potential label error. Okay, how can we evaluate this? We do this with two data sets. We use a simulated one from the car driving simulator where we have perfect labels, and we use cityscapes where we have quite good labels. And then we are going to drop labels or connected components from the ground truth and try to find them with our method. For the evaluation, we are going to use the segment me if you can benchmark. The experimental setup looks as follows. We have a caller input image. We have the corresponding ground truth. We can despawn that car over here, record another ground truth, which is the one that now contains the label error. And we can evaluate our method that is supposed to find that label error with this kind of ground truth over here. Similarly, cityscapes contains ground truth in terms of polygons, and we can drop whole polygons and try to find them with our method and evaluate it with the previous ground truth that is not having any label errors, hopefully. These data sets and benchmarks together convert into a lengthy table. We have many of those lengthy tables in our paper and on the poster, so come visit our poster to learn more about the method and the results. But now you might ask, okay, this works perfectly fine on these tables, and indeed those tables have really nice results, but does this now work on real label errors? Let's have a look at the cityscapes dataset. And indeed, we found traffic lights that were labeled as traffic signs. We found a traffic sign that was completely overlooked in the ground truth. We found a human that was completely overlooked in the ground truth. And we found another person that was labeled as a bicycle. It works also well on Coco and ADE20K with much more classes. Cityscapes has only 19 classes. Coco and ADE20K have 80 plus classes. Results for moderate sample sizes can be found in our paper. We found even a worse situation on the Pascal VOC dataset. Here in the front is a lady that was completely overlooked in the ground truth. At least they labeled the table over here, because here they did not, and it doesn't get better. And this questions the trustworthiness of computer vision benchmarks that the whole community is presenting their results on. And it also raises the question whether we can achieve trustworthy AI actually without any trustworthy data. So if you want to see more label errors, come visit our poster. In future work, we will extend this method to 2D and 3D object detection as well as panoptic segmentation. We want to develop overall dataset label quality estimates and want to provide cleaner dataset versions at some point. So thank you for your attention.